Okay, today we're going to be looking at adding and subtracting rational expressions. So this is very similar to adding and subtracting fractions. We're going to be just using the same rules that we used for fractions, where we're looking at our denominators. We need to have a common denominator. If we have a common denominator, we can just add straight across or subtract. We remember that we keep our denominator the same. If we do not have a common denominator, we're going to learn how to find one. So looking at our first example, we can see that we do in fact have a common denominator of 2x. So we're going to simply just add our numerators, 5 plus 7. And we're going to keep our denominator the same. So we end up with 5 plus 7 is 12 over 2x. And then, of course, we would want to simplify out any common factors. So 12 and 2 are both divisible by 2. So we're going to divide out the 2. And we end up with 6 over x. Looking at our second example, again, we have a common denominator. So we want to go ahead and this time it's subtraction. Now we need to be really careful here with our subtraction because we're going to have to distribute that subtraction sign. So we have 3y minus y minus 8 all over y plus 4. So we need to distribute that subtraction to both terms. So we have 3y minus y plus 8 over y plus 4, which becomes 2y plus 8 over y plus 4. Now here we need to look at, can we factor anything out of our numerator or our denominator? And we should see that we can factor out a 2, and we can rewrite our numerator as 2 times y plus 4 over y plus 4. So we're going to be able to cancel out those common factors of y plus 4, and we end up with just 2. Now sometimes we don't have common denominators, and it's a little bit more complicated when our denominator is an expression containing variables. So what we're going to have to do is we're going to have to look at the prime factorization of each denominator to find their common denominators using their multiples. And we always want to find the least common denominator. That will help us not have to do as much simplifying. So taking a look here, we can see that we do not have common denominators. So I want to look at each denominator individually. So I'm going to look at 10g squared, and I'm going to break that down into its prime factorization. So 10 is 2 times 5, and then we would have g squared. And then I'm looking at my 12g, and 12's prime factorization is 2 squared times 3 times g. So to find our least common denominator, we need to look at each of the multiples. Not just the multiples that they have in common, but every single multiple. So they each have a 2, and we need to take the 2 that has the higher power. So we're going to take the 2 to the second power, and we're going to be multiplying that by our next factor, which is 3. Now, it's okay that the 10g squared doesn't have a 3. That still is going to be part of our factorization. Then we look over here and we have a 5. So we need to multiply that times 5. And then they both have g's. So we need to take the higher power, which would be g squared. Okay, so then we just multiply this all together. 2 to the second power is 4. So 4 times 3 times 5 gives us 60g squared. So our least common denominator is 60g squared. So then from here, what we would need to do is we would need to figure out how to find new denominators, right? So we would need to be changing from our 10g squared. Oops, I'm sorry that doesn't look like a squared. Let me fix that. And we need to figure out what we're multiplying by to get that to 60g squared. So we're multiplying 10 by 6. And just like we did with fractions, that means we're also multiplying our numerator by 6. And our numerator was a 3, so it becomes an 18. And that would be our new fraction with the least common denominator. We're going to do the same thing for the 5 over 12g. In order to get to our 60g squared, we would need to multiply 12 times 5 and g times g. So we're going to multiply our numerator times 5g, so we end up with 25g, not g squared, just a 25g. And we're not going to add these quite yet, but that would be how we create our two new fractions with common denominators.